Okay, so how we're gonna do this is a little bit different from how I usually do things. What I'm gonna do is I'm gonna bring you this question right here from here. I'm gonna tell you the answer to it, and then I'm gonna tell you any misconceptions that we may have from this question that may cause you to get the question wrong. So, as for the question, it says we have three cylinders, identical cylinders, that are filled with unknown quantities of ideal gases. The cylinders are closed with identical frictionless pistons of mass m, and it states that cylinders A and B are at the same temperature of 20 degrees Celsius, and cylinder C is at 80 degrees Celsius. And it wants you to decide whether or not A and B have the same pressure, or if one is greater than or less than, and that goes the same for B and C. So, for our answer, the answer is that pressure A and B are the same because the atmospheric pressure and the weights of the pistons are the same for both of those. The only thing that is changing is with the gases. And in pressure B and C, that's the same thing where the pressures are the same because the atmospheric pressure and the weight of the pistons are the same as well. And that's the only thing that's changing is the temperatures of each cylinder. So in retrospect, A, B, and C are all the same in pressure. So as for any misconceptions, one of the misconceptions is that we assume that pressure is always inversely proportional to volume. And the thing is, that is only valid for equals amount of gas. And we can see that in A and B, that you may assume that the volume, since the volume is bigger in one of them, that the pressure should decide whether or not there's more pressure in one or less pressure in the other. And since these two have different amounts of gas, that makes this whole statement up here invalid, so we can't decide on that. So the second misconception is that pressure is always directly proportional to temperature, which to explain it, it's like as you add pressure, the temperature should rise as well. And the thing is, that's only valid for equal volumes, so that's including the number of moles in the gas, and that's very important to keep in mind. And that's an example of B and C. So we may think that the pressure is different, but since the pressure, the volume, and the temperature are all constant, the number of moles are different in each of them, right? So that just makes since the number of moles in each of the gases are different because this is hotter than B, that means that the number of moles are different and the volumes shouldn't relatively be equal to each other, and that makes number 2 invalid as well. As for some other misconceptions we may have, it's that we may correlate pressure to the height of the piston rather than the weight of the piston. And that's kind of similar to the first misconception I brought up, where we kind of decided the height of the piston decides the pressure, where in retrospect the actual thing that decides the pressure is the weight of the piston, and since the weight of the piston is the same, they are equal to each other. Same thing goes for the second one. It's that people correlate pressure to the molecules in the cylinder rather than the weight of the piston, and that also goes for B and C, to where people think that just because this is hot and the molecules are moving faster, that the pressure should be less or more, and that's not the case. And the pressure that's on the system mainly on the gas, is decided on the atmospheric pressure and the pressure of the piston on the outside. So that's why this doesn't really bring you to the right answer as well. So I hope that cleared up any misconceptions that you may have, and that's all.